Alright, for number 12, you should have graphed a line that started at -4 and its slope was 5 over 1. Then you should have graphed a line for 14 that's y-intercept was at 6 and slope was down 1 to the right 1. 16, your y-intercept was 4 and your slope should have went down 2 and to the right 3. Your 18 should have been a horizontal line at y equals -2. 20 is nonlinear. 22, there's no relation. 24 is nonlinear. 32 is $24. B is 64 minutes. C is 144 minutes. 34A is $671 billion. B is 2008. C is 2013. 36A is $3 for 7,000 hot dogs. And B is when your price is greater than $3. 38A is 7,500. B is when X is greater than 7,500. For 44, you have a cost equation of 5 plus 0.05x. For B, it cost you $10.25, and for C, it cost you $14. Please come with questions over those next time. All right, the next part of the chapter is dealing with graphing piecewise functions. And what piecewise functions are pieces of different functions put together. So if I would just give you the problem, y equals 2x, would you be able to graph it? And you all should because you just did on your homework. So you would go to 0, 0, and you would go up 2 over 1, and then you go up 2 over 1, and up 2 over 1, and down 2 over 1, and down, and so on and so forth. And you would draw a line. Well, now, all we want from that line is a certain piece of it. This part will tell you what piece it wants. And they're telling you it wants all of that except for when x does not equal 0. So, they want everything but this. Sorry. They want all of this, but they don't want it when x equals 0. So when x equals 0, so I'm going to go to my graph, and when x equals 0, and I'm going to erase that part. And it ended up erasing all my line. That's bad. Okay? I'm going to erase just that part right there. And what I'm going to do is make it an open circle there. Because they like this line y equals 2x except for when x equals 0. They don't like that. So, then I read my next part, and it says y equals 1. That's this bottom part, the 1. And they're saying if x equals 0. Right there, what they're giving you is an ordered pair. So we're going to go to y equals 1 and x equals 0, and we're going to put a dot. So when y is 1, x is 0, there's our dot. So we have this line with a hole in it, but a dot above it. So that is your lovely graph. From there, you're going to find the domain, and you're going to locate any intercepts, and you're going to find the range. I always do the graph first before I do any of the other. So, for my domain, we are going to look at our x values from the left and from the right. So if you notice, here's an arrow that's pointing to the left, and here's an arrow that's pointing to the right. So we usually say negative infinity to infinity. But we have to look at our graph and make sure there's no holes or gaps. Well, we have a hole here when x is 0. But you have a dot there when x is 0, so you're okay. If you didn't have that dot there, you couldn't say negative infinity to infinity. You'd have to say negative infinity to 0, and then 0 to infinity. Alright, so our intercepts. We get, that is not an intercept because it's an open circle. So we only get 0, 1. For our graph, we did, and find the range. So our range are our y values. So from top to bottom. Well, if you notice, our arrow's pointing down, so that would give us negative infinity. And our arrow's pointing up, so that would give us positive infinity. However, we have this lovely hole here at y equals 0. Is there any other spot on the graph when y equals 0? Your answer should be no. So we can't say negative infinity to infinity. We have to say negative infinity to 0 and 0 to infinity. Okay, go you? Holy cow, this one they have 3 equations. So the first equation is y equals x plus 3. So graph y equals x plus 3 on your paper. You probably should use pencil because you're going to have to erase some. So I'm going to go up to 3, and my slope is 1 over 1. So I'm going to draw my graph. And there we go. So now I have to pay attention to when they want that part. And they say from -2 to 1. And -2 has a line under it, so it can be equal to -2. So I'm going to go to -2, and I'm going to erase the part of my line that doesn't have -2 on it. So from -2 to the left, I erased. And then I'm going to go to 1, and I'm going to erase from there. So from -2 to 2, or -2 to 1, excuse me, we have that little line segment. That's all they wanted here was from -2 to 1. However, at -2 it's equal to, so we have the closed dot. But at 1, it doesn't have a little equal to symbol there, so we have to have an open circle right there. That's an open circle. So, then the next equation says y equals 5 if x is 1. So that's an ordered pair. So we're going to go to x is 1, and we're going to go up to 5. 1, 2, 3, 4, 5. Right above that blue dot. There we go. So then, our next equation is y equals -x plus 2. So I'm going to graph y equals -x plus 2. So I go to 2, and I go down 1 over 1, 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 and I draw my line. But they only want the line when x is greater than 1. So I'm going to erase everything to the left of x equals 1. So x equals 1 is right here, so I erased everything to the left. It's not equal to 1, so we have an open circle there. So, wasn't that a fun one? So to state our domain, we look from the left to the right. From the left, we don't have an arrow over here. We do have a first dot right here at -2. So we're going to go from -2 to, if we continue on, we have these holes, and we have a closed dot at 1, so they're okay. We continue on, and we have an arrow, so we're going to go to infinity. Our intercepts, it looks like we have an x-intercept at 2, 0, and a y-intercept at 0, 3. And you're done. So now we want the range. So here we look from the bottom to the top. From the bottom, we have an arrow, so we're going to say -infinity. To the top, we don't have any arrows up here pointing up, so we know we're going to stop at that value. However, we have a hole here when y is 1. We have a closed dot here, though, when y is 1, so we keep going up. We have a hole here when y is 4, excuse me. So, we're going to go to -infinity to 4, close the parenthesis. No bracket, because it's not equal to. Then we jump up to 5, and 5 is our only dot, so we just say 5 with brackets. That range was a little bit weird because it jumped there up at the top, so watch that. Alright, so see if you can graph y equals x plus 1 on your own, and pick the part of the graph that x is less than 0. See if you can do that one on your own. So pause the video and see if you can do it. So y equals x plus 1, we're going to graph a linear equation. You might want to go through the right dots. So, and we want it when x is less than 0. So I'm going to start here, and I'm going to go like that. This is the portion of the graph that you want. So we have an open dot there because x is less than 0, it's not equal to 0. So now pause the video and see if you can graph the y equals x squared for x is greater than or equal to 0. So it equals 0, so I'm going to put a closed dot. And my graph for a parabola looks like that. And I'm only going to include the right side of my graph because we only want when x is greater than 0. And there's your graph. See if you can do the domain, intercepts, and range on your own. So pause the video. I would say domain is negative infinity to infinity because there's arrows on both ends, as well as here in the middle when you have an open circle at x equals 0, you still have that closed one at x equals 0, so it works. Your intercepts, I'm going to say, are negative 1, 0, and 0, 0. This one doesn't count because it's an open circle. Your range, I would say, is from negative infinity to infinity. For 1, you have arrows going down and arrows going up. We have this open circle at y equals 1, but right there we have a closed circle at y equals 1. So, yay go you. Alright, see if you can graph these on your own. So we got y equals the absolute value of x from negative 2 to 0. So y equals the absolute value of x is a v. So we want from negative 2 to 0, so I'm going to erase all that I just drew, and I'm only going to go from negative 2 to 0, and at 0 I have an open, can't get any of this right, I have an open circle. There we go. Alright, for the second, or the next one, it says y equals 1 if x is 0. So for that, it's just an ordered pair. When x is 0, y is 1. And the last one is for x cubed if x is greater than 0. So x cubed when x is greater than 0. X cubed goes through here. And at 1, you're at 1. At 2, you're at 8. And your graph just continues to go up. I made that still open there because we're greater than 0, we're not equal to 0. So if we look for our domain, we don't have an arrow, but we start at negative 2 and it's closed. And we go, when we have an arrow, so infinity. Well, let's check in the middle here. When x is 0, it was an open circle, but x equals 0 up at the green dot, so that's okay. For our range, we start at the bottom. There is no arrow down here, so I need to figure out where the first dot occurs, and that's at 0. However, it's an open circle, so we can't include it, so we have a parenthesis. And it looks like our graph continues up, so we're going to say infinity. Yes, our graph over here stopped there, but this part continued on up, so we got to include it. All right, intercepts are 0, 1. You shouldn't include 0, 0 because it is an open circle. This is one of the harder things of this chapter, so please come with questions about this next time. We will be working extensively with this in class as well as the next few days. So please come with questions over this next time.